Now, I'm sorry, I had a dead battery, so I just had to, that's why this video will be in two phases. So, let's continue from where we stop. I'm talking about formation of ionic compounds here now. That's our next thing. Formation of ionic compounds. Formation of ionic compounds. That's where we are now. Okay, now, in the formation of ionic compound, there are three stages. There are how many stages? Three, just three stages. The first stage, number one, right? Number one. The metal atom loses all its valence electron to form a stable cation. The metal atom loses all its valence electron to form a stable cation. That's the first process. That's number one. The metal atom loses all its valence electron to form a stable cation. That's number one. In a process called oxidation, when an atom loses electron, I'm supposed to oxidize. We call that process oxidation. In a process called what? Oxidation. Full stop. When we be what's oxidation now, I've given you the full definition of oxidation now. An atom is a process in which an atom loses electron. Okay. Now here, continuation. The heat energy absorbed during this process. The heat energy absorbed during this process is ionization energy. We call that energy ionization energy. That's the first stage. The metal loses electron. First stage. Stage 2. The non-metal gains the electron. The non-metal gains the electron to form stable anion. The non-metal gains electron to form stable anion in a process called reduction. When an atom gains electron, the process is known as what? Reduction. In a process called reduction. That's reduction. And the heat energy absorbed during this process here, the heat energy released during this process, we call that one electron affinity. Electron affinity. Ionization energy is for metal, electron affinity is for what? Non-metal. That's stage number 2. Stage number 3 here. The opposite ion combine by electrostatic force of attraction. The opposite ion combined by electrostatic force of attraction to form an extremely strong electrovalent bond. It is the reason why I said the opposite charge. That's this between metal and non-metal, positive charge and negative charge. So now that's the third stage. They will combine. The opposite ion combined by electrostatic force of attraction to form an extremely strong electrovalent bond. Now, that electrostatic force of attraction, force in one, I said that's when I was defining chemical bond to you guys. I think this is what is a cohesive force. So that force of attraction, Timo mentioned saying, that means I'm talking about the bond. And that bond that is present there is what we call what? Electrovalent bond or ionic bond. Thank you guys. Okay. Now, when they are combining, the heat liberated, they also liberated. When I say liberated, it means released. The heat liberated during the process is called a lattice energy. Lattice is called a what? I've mentioned one, ionization. That's the heat energy released by metal. Energy absorbed by metal, rather absorbed. This one is absorbed. I mentioned electron affinity. This one is what? Released by non-metal. But when the two now combine, they form what? They release what? Lattice energy. That is energy. That is the energy they are going to release. Now let me give you some example. Let's use these processes to explain how electrostatic force of attraction occur. Let's talk about combination of calcium and fluorine atom. Combination of atom and fluorine, of calcium and fluorine atom. Combination of calcium and fluorine atom. Combination of calcium and fluorine atom. Let me just use Olemagba. Just use the symbol. Combination of calcium and fluorine atom. Now, what's the first thing that I said will happen? Number one, I said the metal will lose its elements. Now its electron. Metal will lose its electron. Now calcium atom. Calcium atom. After I say calcium atom, okay. Let's do this. Calcium atom. It is Ca20. This is electron configuration. Calcium has a caliber 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. That's electron configuration of calcium. You guys have been taught electron configuration. The quantum numbers. We call them the quantum numbers. You guys have been taught, and then you're talking about some principles. The principles I use here is called the Aufbau principle. I mean, along the line, we come there. And you know that calcium is number 20, electron configuration. Calcium is number 20, that's 2882, right? Okay, and it is a metal because it is having 2 as its valence electron. It's a metal in group 2 of the periodic table. It's a metal in group 2. Now, the first step, I said a metal is going to do what? Lose all its electrons. Metal loses, it's going to lose its 2 valence, going to lose its 2 valence electron to form calcium. When you see these 2 plus, it means that it has lost 2 electrons. That has an argon structure. That has argon structure. That is, it is assuming a noble gas configuration. In the beginning of the first video, I mentioned that argon is a noble gas. So let's look at this. To lose Ca, lose 2 electrons. Ca2 plus, 2e minus. Lose 2 electrons. Maybe by telling it is 2882. But maybe I already can 288. Lose 2 electrons. That's the first phase of electrovalent bonding. That's the first phase. This is going to obtain an octet configuration. You can see it has 288. The last number of electron here is what? Is 8. So it is obtaining an octet configuration. That's that about that. Now number two phase, I said the non-metal as well. The non-metal is going to accept the number of electrons. Listen to something. The number of electron gained by a non-metal must be equal to the number of electrons that the metal has lost. Since I'm talking about calcium and fluorine here, which means if calcium loses 2 electrons, fluorine as well must gain that 2 electrons. Because if calcium lose 2, fluorine will gain 1. No, eye to ba lose not lo ma gba. Ebi n pa ensin mo fún 20 naira pé kó ná gbogbo ẹ mo fẹ́ kó ná ni. Ebi n pa fluorine, calcium wá fún ni pé okay o 500 naira re lọ fi jẹ kulikuli àtẹ̀pà. Ó lè fún lọ fi jẹ kó fi mu gààrí. Change it. So that's electrovalent compound for you. The number of electrons lost by metal must be equal to the number of electrons gained by non-metal. Okay, let's talk about stage number 2. Stage 2, number 2. Roman figure 1, Roman figure 2 now. Roman figure 2 now. Roman figure 2. Fluorine atom. Fluorine atom. Don't mind me. Fluorine. Fluorine is number 9. Abi? Fluorine has an integration of what? 1s2, 2s2, 2p5. Yeah, 2 plus 2, 4. Yeah. It is an halogen. That's the family name for all elements in group 7. In group 7. That's the family for all elements in group 7. Accepts only one electron. Only one electron to complete its valence shell. Yeah, shell. And form fluorine ion that has neon structure. That is fluorine here. F wọ́n gba kíní electron plus Z minus ó wá form F minus. You look at this here, fluorine is number 9. This here is 2,7 initially, but here it has become 2,8. Now I said something earlier. Mo ní a number of atoms tí calcium values ní fluorine gbọ́dọ̀ gbà. Àbí? But nígbà tá a máa ṣe calcium ó lose kíní mélòó? Kíní méjì. But fluorine ò láǹfààní àti gba méjì, ẹyọ kan ló gbà ní fluorine, ẹyọ kan lè gbà. Am I communicating? Now ó kù electron ẹyọ kan yẹn nílẹ̀. Ibo electron ẹyọ kan yẹn máa lọ. That means pé calcium will have to combine with 2 fluorine. And even we have 1 electron, it's going to combine with just 1 fluorine. But now because we're having 2 electrons on ground, calcium will combine with 2 fluorine. Can the fluorine react pẹ̀lú aluminium say Al? Aluminium will lose 3 electrons. Don't suppose fluorine will react pẹ̀lú aluminium. Aluminium will react with what? 3 fluorine. Am I communicating? It's going to react with what? 2 fluorine. So another fluorine máa wá again. We are going to have another fluorine. Ìyẹn náà máa wá gba kíni? The electron. Am I communicating? Ló fi jẹ́ pé electron yẹn máa tán lẹ̀. Gbogbo méjèèjì tí calcium lose ní fluorine gbọ́dọ̀ gbà. Gbogbo ẹ̀ ló gbọ́dọ̀ gbà. Don't forget that. Now stage 3. Stage 3. Stage 3. Roman figure 3. Stage 3. To form a neutral compound, write that. To form a neutral compound, one calcium ion, after writing the ion, write Ca2+. One calcium ion combine with 2 fluorine ion. 2 fluorine ion. After the fluorine ion, write 2F minus. One calcium ion combine with 2 fluorine ion to form what? Calcium fluoride. Here now, one calcium ion, Ca2+, combine with 2 fluorine ion. 2 fluorine ion here, we're having 2F minus to form what? This is Ca2+ with what? F minus 2 fluorine ion. But simply this, we can simply write this as CaF2. Ó ti di pé 2 fluorine ion ló fi wá. Ibi báyìí láti máa ní ọ̀nà tá máa ń gbà fi kọ chemical formula for electrovalent compound. How do you write the chemical formula for electrovalent compound? They use a law that we call the inverse ratio. Don't forget. They use a law that we call what? The inverse ratio. That inverse ratio, I'm having calcium, Ca2+, mo fẹ́ kọ chemical formula wọ́n fún mi ní calcium fluoride. Okay o. Adesari, no, my name is Adesari Adegbagi. Okay o. Adesari Adegbagi o. My chemistry teacher gave me an assignment. Write the chemical formula for calcium fluoride. Okay, calcium fluoride. Fluoride comes from àkọ́kọ́ kọ sílẹ̀. Calcium fluoride. Okay, calcium is calcium. Fluoride comes from fluorine. Okay. What is the valency of calcium? 2+. That's calcium is number 20. It's a metal. It has 2 electrons. Fluorine F-. Ìtawà ń pè ní inverse ratio ni mo fẹ́ ṣàlàyé. Inverse ratio means this one is going to accept the valency of this, while this one is going to accept the valency of this. Eléyìí máa gba 2 èrú eléyìí sọ pé -1 minus kàn fi 1 yẹn sí ni 1 bẹ́ẹ̀ àkínkọ́. So this one will now be CaF2. Ó rí pé fluorine méjì náà ló ṣe react. And then it is okay. Write the formula for aluminium oxide. Aluminium, okay, Al nìyẹn. Aluminium is number 13. Ó máa lose 3 electrons, 3+. Oxide comes from oxygen. Okay, O2- lòun tiẹ̀. Inverse ratio náà tún ni. Eléyìí máa gba eléyìí, eléyìí máa gba eléyìí, eléyìí máa di Al2O3. That's how we write the chemical formula for electrovalent compound. Am I communicating? There are some situations whereby the numbers will be equal. For example, calcium oxide, Ca2+ and O-, 2-, O2-. Because it is 2+ and 2-, one equal, méjèèjì máa cancel ara wọn nígbà kankan, máa lọ kọ Ca2O2. This is wrong. Am I communicating? This is what? Wrong. Because they are the same. 2+ and 2-, they are the same. The formula will now be CaO. O máa cancel ara wọn. That's how we form electrovalent compound. What I just explained here now, using calcium and fluorine, this is a why question. And how did they ask that question? They said, illustrate the change in the electronic structure of fluorine when it reacts with calcium. That's just the illustration. You just take the stages. It's a why question. I have the question here. I write down those questions on this topic, so I just have to do that to explain. Now from there, we have characteristics of electrovalent compound. We'll be stopping there for now. Characteristics of electrovalent compound. 1. Characteristics of electrovalent compound. Number 1. Electrovalent compound exists as aggregate ions of opposite charge. They exist as aggregate ions of opposite charge, which are held together by strong electrostatic force. They exist as aggregate ions of opposite charge. I've been working this morning. They exist as aggregate ions of opposite charge, which are held together by strong electrostatic force. That's number 1. Number 2, they have high melting and boiling point due to the strong electrostatic force. They have high melting and boiling point due to the strong electrostatic force. Number 3, in solid state, their crystals are brittle. That is, when they say something is brittle, it's easy to break. In solid state, their crystals are brittle and electrically neutral. In solid state, their crystals are brittle and electrically neutral. Hence, they do not conduct electricity. Tí ma fẹ́ fa iná, wáyà iná, ní ma fẹ́ fa iná, tí bá da iyọ̀ sílẹ̀, wá fi wáyà gbabẹ̀ kọjá or something, nothing will happen. Kò ní múná wá, because they just exist as what? Normal ion, according to Arrhenius theory. That's, they have not dissociate. So normal table salt will not conduct electricity. That's number 3. In solid state, You can just say simply that what I stated there in simple form. Or just say in solid state they do not conduct electricity. That's number 3 for you. Now number 4, infused or molten state. Infused or molten state, they conduct electricity. Ibẹ̀ they have what we call mobile ion, hydrated ions, tó ti move, that can carry the charges from one place to another. Infused or molten state, they conduct electricity. That's number 4. Number 3, they dissolve in water to give aqueous solution that contain hydrated ion. They are simply, in simple form, you can just say they are soluble in water. But if you want to prove to them that, wow, chemistry 1 layer, okay, they dissolve, you can tell them they dissolve in water to form what? Hydrated ions. So in simple form, just say they are soluble in water. Now, let me say something. When they form hydrated ion, they form what we call electrolyte. They form what we call what? Electrolyte. And when they say what's an electrolyte, when someone asks you that what's an electrolyte, you will still learn it again in higher class. You can just tell them an electrolyte is a compound, either in solution, fused or molten state, that conducts electricity. That's in simple form. That conduct electricity. But for your senior will know that if they tell me such definition, I won't mark it for them, because there is something that will happen. It gets decomposed in the process. But for you, they just say that's an electrolyte. Okay, the last one, number 6. They are insoluble in organic solvents. They are insoluble in organic solvents such as ethanol, petrol, kerosene, propanol. They are insoluble in them, in organic substance. They will not dissolve in them. That's why they don't conduct electricity in organic substance. Thank you very much. I pray you guys will have more knowledge and understanding. If there is any question, you guys can reach me through either Master Goki or something. Either Master Goki, use Master Goki. And I think some of your seniors have my WhatsApp number. So you can just text me your name, then your question immediately. Your name, then your question. The Lord will be with us. Thank you.